easily plastically deformed because the compressive stress developed by the tool on the job is larger than the compressive strength of the job, so that the job surface is plastically deformed. Okay. During this machining during machining, we give some work through tool to the job. That is why stress is formed and ultimately the job surface is plastically deformed. So this work, because according to thermodynamics concept, we know work is high grade energy, high level of energy, or it can easily convert it into low grade of energy, or lowest form of energy is called heat. So that during machining, heat is automatically generated. This is the one concept. Another one is tool chip interface region. There is a frictional force, so that the frictional energy is occurred in tool chip interface. So that frictional energy is also ultimately converted into the low grade of energy, that is heat, or lowest form of energy, that is heat. Okay, first of all, we draw a tool chip interface region. This is shear plane. This is our chip. This is our chip. Okay. So first of all, when tool is penetrated on the workpiece, their job is plastically deformed in shear plane. Shear plane, and first deformation occurred in shear plane. So shearing deformation is occurred. So here, because here the material is plastically deformed, so that for ductile material we will know our stress strain diagram. This is our proportional limit or elastic limit. After that, yielding occurs, then ultimate point and breaking point. So this portion is called yielding. This portion is called yielding. After that, lower yielding to ultimate point is called strain hardening. Due to strain, material is very hard. So during strain hardening, some energy is released from the work job or material. So this energy is also converted into lowest form of energy, that is heat. So that the major portion of the heat generation is the shear plane region, that is called primary shear zone. Maximum heat is released in this zone. Almost 95% of total heat generated during machining is at the shear plane. Okay. Another point is tool chip interface with this line. Tool chip interface. Here frictional force is occurred during machining. so that frictional energy is converted into heat. So this zone is called, a green zone is called secondary shear zone. Secondary zone. Okay. Here also heat is generated. It is almost 4 to 5% of the total heat is generated during in that portion. Another here auxiliary zone is generated at the base bottom side of the tool. At the bottom side of the tool. It is during the flank phase and the machine phase. This zone. Sometimes it is rubbing each other. So here also after rubbing the heat is also generated. It is almost 0.1%. Okay. The primary shear zone is the maximum heat is available. Now if this heat is remain at this point, then the tool may be also plastically deformed after some time. Okay, for long time machining process, tool the principal cutting edge or auxiliary cutting edge is also may be plastically deformed, or the machining uh, idle machining is not done, so that we provide a rake surface. Through this rake surface, chip is continuously flowing over the rake surface and goes to the other direction, so this direction. Okay, so actually chip, what is the function of chip? Chip is actually carrying the most of the heat through this direction or through rake surface, because maximum heat is generated at the primary shear zone. This heat really transfer to the chip, and chip carry away the maximum heat which is generated at the shear plane. So the tool surface is not blunt very fast at very fast of the machining. So the machining, idle machining, is almost occurred. Okay, this is our chapter, heat generation of during machining process. Thank you.